Okay, so as of now, we got your particular solution y p of t is equal to k. Now, rewrite your given equation, the given differential equation. What was the given differential equation? The given differential equation is 5 dy of t by dt plus 10 y of t is equal to 2x of t. Now, in this, we substitute, let it be 3. Now, put 2 in 3. Substitute this particular solution, particular output yp of t into equation number 3. So how you can rewrite equation number 3? It will become 5 into d by dt of k, correct? Y of t is k. Y of t is k. Here also we need to put. So y 5 into d by dt of k plus 10 into d by dt of, sorry, 10 into k, correct? Yeah, 10 into k. There is no differentiation over there. 10 into k equal to 2 times of x of t to u of t, which is given. This is given. I repeat once again. After observing your input, which is a constant value, it is understood that your particular solution will be constant. That is why from the table I took case number 1 and your particular solution is k. Now, based upon this particular solution, you should substitute in the given equation, that is 3. Equation 3 is given. The differential equation is given in your question. In that, we are going to substitute. So, the first term, it is understood that first term, it is 5 into derivative of y. That is derivative of your particular solution, that is k, plus 10 into k equal to 2 into x of t. What is x of t? X of t is 2u of t. Now, what is this? D by dt of k. D by dt of k. 0. Correct. Derivative of constant is 0. Okay. So 5 into 0 plus 10k equal to 2 into 2, 4. U of t, you can consider this as 1. U of t is 1. Correct. So right hand side it will become 4. So 10k equal to 4 or k equal to 4 by 10, which is equal to 2 by 5. This is your output. As we have already told y p of t was k, from which one? Equation number 2. You just substitute this in equation number 2. Substitute the value of k in the solution, in the particular solution. Particular solution is y p of t is equal to k. So therefore we can write y p of t as 2 by 5. Let it be equation number 4. So now you got the particular solution. Now to write the forced response, what we have to do? Forced response is nothing but natural response plus particular solution. So y f of t is equal to, what is your natural response? It was from equation number 1 you got c1 e to the power minus 2t. Correct? c1 e to the power minus 2t plus the natural response is c1 e to the power minus 2t and particular solution was k, that is nothing but 2 by 5. Is your answer is complete or still you have to do something? Can you tell me?
So finding C1.
Finding C1. So for that we must make use of, very good, we must make use of our initial condition. So till now I will repeat it once again for the latecomers. So what I have done is the given differential equation and the input is also provided. Input is 2u of t. So first what I will do is, I will find the natural response. Then we have to find the particular solution, and then we need to add those to get the final forced response. So first, to find the natural response, what I will do, I will set your right hand side as 0. So it becomes 5r plus 10 equal to 0. Your characteristic equation. From this I solved the value of r, only one root I have, because it is a simple linear equation and it is not a quadratic equation. If you got a quadratic equation, you will get two roots, but here it is a linear equation, so you have only one solution or one root. So based upon that root, your natural response is c1 e to the power minus rt. R is your root, isn't it? R is 2, sorry, minus 2. So c1 e to the power minus 2t, equation number 1. Now after finding the natural response, next one is particular solution. Particular solution means we have to take the particular output for the particular input. Particular input is constant. Why it is constant? It is given that it's 2u of t. U of t, you know, it is 1 for positive cases. So 2 into 1 is equal to 2. It's a constant. Therefore, your particular solution will be k according to the table. Now, this solution you need to substitute in the given equation. So all of you have to write the given equation once again. Let it be equation number 3. In that you need to put instead of y of t. So 5 into derivative of k plus 10 into k equal to 2 into x of t. X of t is given as 2u of t. Derivative of k is constant. I mean, derivative of k is 0. So 5 into 0 plus 10 into k equal to 4 u of t. U of t is 1. So it will be 4 itself. From this, you found the value of k. After finding the value of k, go back to the solution of particular solution given in equation number 2. From that, you got y p of t as k, but k is 2 by 5. So you can write y p of t as 2 by 5. And from theory, already we know that the forced response is equal to natural response plus particular integral. Correct? Forced response is equal to natural response plus particular integral. I mean particular solution. Particular solution is 2 by 5 and natural response is c1 into e raised to minus 2t. But from this we need to find c1. For that I will go for the initial condition. Now check your question if there is any initial condition. Check your question if there is any initial conditions given. Do you have any initial condition? Like y of 0 equal
No, sir.
no. So if there is no initial conditions given in the question, you have to assume 0 as initial condition. So you can write y f of t as 0. You can assume y f of t as 0 as initial condition. If it is not given, we have to assume it as 0. Please make a note of it. If initial conditions are not given in the question, then we must assume it as 0. So 0 is equal to c1 e raised to minus 2t plus 2 by 5. Sorry, 0 is equal to c1 e to the power 0, correct? We need to put t as 0. Substitute t as 0. So t e to the power 0. c1 e raised to 0 plus 2 by 5. That is c1 plus 2 by 5. c1 equal to minus 2 by 5. Now you can put this in your final answer, the value of c1. So the answer will be y f of t equal to minus 2 by 5 e to the power minus 2t plus 2 by 5. This is your natural response. This is your particular solution or y p of t. Students, you have to be very careful while finding the values of C1 and C2. You are going to find the C1, C2 only at the end, not at the end of your natural response. After finding the natural response in terms of C1, C2, you just stop over there and proceed to the particular solution. Then you have to add the particular solution as well as the natural solution together after finding K1, K2 values. Okay, as of now you have only K because it was a constant, so you have only K. But in coming cases, if you take the second case or third case of the table, you will be dealing with K1, K2 and all. So in those cases, we need to find K1, K2. Then that particular solution you need to add along with the natural response. Then only you have to find or you have to apply the initial conditions. I hope it is very clear. Initial conditions you are not going to apply as soon as you finish your what natural response. You have to wait until you get the particular solution and then you add with the natural response. Then only you are going to apply the initial conditions and finding C1, C2. Okay. Is that clear for you?
So can you show the previous slide?
Yeah. Any doubts? After finding the forced response, that is C1 e raised to minus 2t. This is your natural. This is your particular. You have added these two. Then only you will apply your initial conditions and finding the value of C1. If initial condition is not given in the question, simply you can assume it as 0. At time t equal to 0, your initial condition will be 0. Any doubts? I hope you have taken down the notes. Should I repeat the steps once again? First step is you will write your RHS as 0, means your input as 0, and then you will find the characteristic equation and solving the roots. After solving the roots, what you have to do? You have to write your natural response based upon the roots. There are three conditions now. To write the natural response, there are three conditions. If the roots are real and distinct, one condition. If the roots are equal and real, another condition. If the roots are complex conjugate, you have the third condition. Based upon this, you will write your first equation, that is natural response. Then you have to move towards a particular solution. For a particular solution, you need to study the table and take your output, t of t. Then you need to apply into the given equation. Okay, in the given equation, you need to substitute the particular solution, and from that you need to find the value of k. After finding k, you finalize with your particular solution and add with your natural response. Okay, then you get your yf of t, but still it is complete because you did not find C1 as of now. So for that, last you have to apply your initial conditions and find the value of C1 and rewrite your output. Simple, no? It is very simple. Okay, you can score maximum marks in this particular section. Okay, one more question. Find the zero state response. Find the zero state response for the system given by 5 dy of t by dt plus 10 y of t equal to 2x of t with input x of t is equal to e raised to minus t u of t. What do you mean by zero state? Zero state means forced response. It is another name of forced response. Please take it down. In the theory part, I already told you. Forced response is zero state. Natural response is zero input. So it is understood that you have to find the forced response here. For this, you need to find the natural response first. Please take down the question. Then you can find the natural response and tell me the characteristic equation. After setting your right hand side 0, your characteristic equation will be 5 dy of t by dt plus 10 is equal to 0. So it will be 5r plus 10 equal to 0, r equal to minus 2. Based upon this, your natural response will be t1 e to the power minus 2t. Equation number 1. We are not going to find C1 as of now. We will keep hold. After finding the particular solution only, we are going to find this. Now coming to the particular solution. All of you observe the table and tell me. Before that, you just note down your input. What is your input? Input is e to the power minus t, u of t. Based upon this, go to that table. Yeah, this is your table and find the output yp of t and tell me. What is A? What is small letter a here? Compare with your given input and tell me what is small letter A.
One.
1, yes. In the question, it is given x of t equal to e raised to minus t u of t. Here it is e raised to minus a t u of t. So it is understood that a is 1. So your solution will be k e raised to minus t. Don't bother about capital A. It will be there. It is 1 only. So based upon that, anyway, we have to incorporate k. So k into e to the power minus t. Why I have thrown this a out is because small letter a is 1 here. So k e raised to minus t. This we have to take and substitute as yp of t. So our yp of t will be from the table k e to the power minus t, equation number 2, and kindly take down the given equation again. All of you write the given equation again. What was the given equation? 5 dy of t by dt plus 10 y of t equal to 2x of t. Let it be equation number 3 and substitute 2 in p. Okay, I will stop here and remaining I will give you homework. Okay, and all of you can post your answers in the Google Classroom once you get this. Okay. Thank you all. You have to revise before coming tomorrow. Please revise how you have done the natural response and how you have done the forced response, and then you come tomorrow's class. Thank you all.